Our first question is, why do you have to be so mean? In this question, we'll be discussing how we can concisely describe a data set. In other words, if we have a very large data set, how can we describe what's in that data set in one single value? Can I pick just one number that describes the data set? And you could think, if I were using something like pandas, I could do a describe or an info, and I could figure out things like what the minimum value is and the maximum value. Let's take a look at our data set again. And we can see there's a bunch of values in it. And we could say, oh, there's a minimum value at around 1, there's a maximum value at around 8, the sum of all the values is something, but I know some things immediately jump into your head. Jumping into your head the moment you see something like this is, I'm going to describe this in terms of the mean. And what you can think that mean is, that average, is it's taking every single one of these points and it's reducing it to a single scalar value, and assuming that single scalar value is representative of this data set, tells us something interesting about that data set. And so we can take this data set and we can compute what the mean would be. And of course, we need to do one small thing here, compute what the mean would be. And you can see the mean's around 4.95. And that can tell us something. It can say most of the values are somewhere around this 4.95. And we'll talk about what the intuition for the mean is in a moment. But the moment I say something like mean, you might think of that common joke about what you should study in college. And they say if you take a look at all the different majors and you take a look at the average starting salary for all the different things you could major in, there's computer science, there's business, but for some reason, if you look at the average starting salary for people who major in geography, it's enormous. Why would that be? Well, as you might know, Michael Jordan majored in geography when he was in college because he thought, I'm going to be traveling around the world, I better know where I'm going to be going. And you can think Michael Jordan probably did just a little bit better over his career than maybe the average geographer, and he's going to be skewing this data. One thing that we know is when we talk about things like the mean, very large outlying values definitely change what that mean is, and it moves it around. And so it's not that representative. And immediately we know, intuitively, maybe we need something better than the mean. Maybe we need something like the median. And the median represents some value close to the center where half of the values are above it and half of the values are below it. And we might say even though the mean starting salary for a geographer may be enormous, the median maybe isn't that ambitious. Maybe it's a little bit within the realm of competitiveness with the business majors and the literature majors and the computer science majors. And the moment we start talking about things like the mean, the median, we naturally reach for something like the mode. And we say, oh, there's this thing called the mode, which value appears the most often. And you can think with these three single values, we can describe something interesting about the data set. We can say the values seem to be centered around 4.95. 4.92 is the middle point, the exact middle point, for which half of the values are above it and half of the values are below. And we can say the value 5.36 seems to appear a number of times. It appears 11 times. Now, one thing that I may not be able to answer for you, and I don't know that I have an answer for myself, is why on earth is mean an operation on a NumPy and D array? Median is something that you have to import from NumPy but does not exist on the NumPy and D array. And mode doesn't exist in NumPy. You have to pull it from scipy.stats. I don't know. But it is definitely the case that if we were to repeat some of these examples using pandas, we definitely have a little bit nicer of an API here. We can do series.mean, series.median, or series.mode. And interestingly enough, notice that series.mode, it doesn't return a scalar value. It returns a series because there could be multiple modes. There could be multiple common values. And so what pandas is saying is, well, I'm going to return what those multiple common values are. I'm going to use an aggregate structure as series in order to do that. Now, one thing that I want to share with you about the mean, the median, and the mode is that they're actually all views of broadly the same thing. And this is something that I really like to think about when I think about what do these summary statistics really mean. How are the mean, the median, the mode different? Because we have a common sense understanding of what they are. The median, half the values above, half the values below. The mean, some sort of central portion. The mode, the most common value. But in fact, we can describe these three statistics in almost identical terms if we think about them in terms of a measure of the aggregate discrepancy. Now, I don't want to get too deep into things like error functions and how do we minimize error. This is something that will come up in future videos. But if we think about it, here we have our data set. And if we look at all the numbers from the minimum value in this data set, which I'll tell you is 0, and the maximum possible value in this data set, which is 10, and we look at every value spaced out by, say, 100th, and we take every single one of these values, and we see if that value is equal to the values that are there. So, for example, we say, how many times is 4.95 in the data set? How many times is 4.96 in the data set? How many times is 4.97 in the data set? So we just do an equals in NumPy. We do a sum over that axis, and then we maximize over that. Well, that would be the maximum number of times we see that value in that data set. And if we index into it, we can see here 5.36. This is the mode. In other words, what we can think is the mode is actually a value that we've chosen in order to minimize a metric of discrepancy, where that metric of discrepancy is either you match or you don't match. If you look at this in a more consistent formulation, or at least consistent with how we're going to formulate the median and the mean, what you can think is if we set for each particular possible candidate value either a 0 or a 1, 0 meaning you did match, 1 meaning you didn't match, and we sum those up, and we figure out what the minimum choice is that we could have, that is an exact correspondence to what the mode is. And that's exactly what the mode is. It really is just a measure of discrepancy that's either you have matched fully or you didn't match fully. And where that might be useful is if we were to play that same game with the formulation that looks almost identical, except where our measure of discrepancy has changed very slightly. Instead of saying it's either a 0 or a 1, if you match or you don't match, we're going to say we're going to measure the distance from the candidate value. That's just the median. All the median is an aggregate measure of what the total distances are from the candidate value. And if instead of looking at the absolute value of that distance, you were to look at the square of that distance, that's the mean. It turns out that for our summary statistics, the mean, the median, and the mode are all statistics that are measured in broadly the same way. It's just some way to capture some notion of what's the best possible candidate value I can choose? Best in what sense? Best in minimizing some discrepancy. What do you mean by discrepancy? Exact match, distance, or distance squared? Now, the moment I say things like mean, median, and mode, and I talk about where the mean, the median, and mode can be somewhat confusing or somewhat misleading in terms of describing our data set, it leads us to a very fun little exercise. If we have a sample data set, and for that sample data set, we can compute the mean and the median. Sorry, the mean, the median, and the mode. And we take that data set, and we make a copy of that data set. And we start making changes to that data set. We can see places where we can significantly and meaningfully change the data, but the mean, the median, and the mode doesn't change. So for example, if I were to add one enormous value to this data set all the way off in the tail, you can see it changes the mean significantly, but it doesn't really change the median, and it doesn't change the mode. And one interesting thing that you can see from this is, did the data set change? This is like Michael Jordan being counted among all the geographers. Well, I don't think the data really changed. We just had one enormous outlier. And so you can see the mean has this sensitivity to these outliers that the median and the mode do not. In a very similar sense, if we were to add 1,000 values clustered around the mean wouldn't change. But you can see that the mode definitely could change, and the median could change. In a very similar sense, if we were to add values above and below the mean, we had a bunch of values above the mean and a bunch of values below the mean. We are changing the data set. We're adding a bunch of values to this data set. You can see the mean doesn't change, the median doesn't change, but we can change the mode. And in a very similar sense, if we add a bunch of values way off into the distance and then add a bunch of values in the negative, if we keep these balanced, then we can move things like the median around, we can move things like the mean around. We can not change actually in this case I should say, what we should see here is we should see that we wouldn't change the mean, the median, or the mode, even though the data set has significantly changed. And so there is a limitation when we use these very simple summary statistics because we can see inconsequential changes to data sets having consequential differences in the summary, consequential changes to the data set having inconsequential changes to these statistics, and so it's not that perfectly describing what's going on with our data set. We need to find a better approach.